Good evening, students. Today I will discuss about the atomic structure, and afterwards I will continue with the discussion of the radioactivity. Okay, so first discuss about the atomic structure. So initially scientist Dalton has proposed the atomic structure or atomic theory. All of you know that he had said that the atom is the smallest particle of any substance, right? Afterwards his atomic theory has been discarded, and then Amadeo Avogadro has introduced his his concept of molecules, and afterwards further discussions. J.J. Thomson was there, who discovered the presence of electron inside an atom. Afterwards Goldstein was there, who discovered the proton, and later, after the discovery of the proton and electron in a atom, J.J. Thomson has again proposed the palm pudding model. Afterwards, the Chadwick or Sadwick, whatever you can say, has discovered the presence of neutron in the atom. Okay. Afterwards, that Rutherford was there, who had proposed the atomic theory, or atomic model, how the proton, electron and neutron, basically neutron was not discovered yet then. So he first introduced or given the concept of the atomic structure, that is how the electrons are there in an atom, inside an atom, what is nucleus, by his alpha particle experiment. Afterwards, further research orientation was there, and further Niels Bohr was there, who discovered or who proposed the original atomic theory or the atomic configuration of the elements, right? So this is the so far the innovations. And afterwards, after the Niels Bohr, there was Compton, Max Planck was there, who has further enriched the research. And nowadays we all know that inside an atom there is a particular place which is called the nucleus, and that nucleus contains proton and neutron. Proton is positively charged, neutron is neutral, and with this the boundary to this nucleus there are orbits are there which consist of the electrons. All of you know that up to 1 to 20 the structure of atoms, I think all of you know that it follows the rule 2n square, right? It follows the 2n square, where n is basically the number of orbit, right? If n equals to 1, then what will be the number of electrons in the first orbit? That will be 2 basically. If n equals to 2, then it will be 18. If n equals to 3, then it will be 18. And thus it goes on, right? So this is the basic concepts. All of you know about it very well. Okay. Now I will recapitulate the thing is that what is the atomic number. So initially, before this, if I go to the hierarchy, then what I can say that there are matter. If I break this matter, from this matter what we will get? We will get some compounds, right? If we break the compounds, what we will get? We will get basically from this compound we will get some molecules, right? From these molecules, what we will get? We will get some elements, and from these elements, if we break it, we get basically atom, right? And further breaking of atom, we will get the 3 major particles, that is proton, neutron and electron. Proton is positively charged, this is neutral, and this is negatively charged. Actually, I am saying that there are 3 particles in the nucleus, nucleus of an atom, but actually there are total almost, nowadays it has 64 subparticles in a nucleus. The name may be, suppose pi meson is there, pi 0 is there, pi plus, pi minus, sigma. Like this, some particles are also present in that nucleus. So this is the quantum physics part. So now it is, for the interest, for the growing of the interest, I have said it. Okay. So inside an atom, what do you mean by the atomic number? The atomic number is basically the number of proton. Okay, number of proton is called the atomic number, right? Clear? Now we all know that in an atom, the number of proton is equal to the number of electron, right? Is equal to the number of electron, right? But the thing is that for the definition of the atomic number, we only consider the number of proton, not the electron. Basically, the thing is that electron number can be changed. All of you know that electron number can be changed, right? For the purpose of for the concept of valency, for reaction purposes, this electron number has been changed, can be changed, right? But the proton number cannot be changed. If the proton number changes, then the element also changes, right? So therefore, for the concept or for the definition of the atomic number, we only consider that the number of proton present in an atom, right? What is the mass number basically? So mass number is nothing but the total number of proton and neutron present in an atom or in a nucleus of an atom, right? So now the thing is that I will discuss about what do you mean by isotope, isobar and isotone. What is isotope? Isotope is nothing but some atoms have same proton number but different mass number. So these atoms are called isobar of each other. Next, isotope. Sorry. I think I have confused. Same mass number but different proton number. They are the isobar. Okay, correct. What is isotope? Isotope is that same proton number but different mass number. They are the isotope. And what is isotone? Isotone is different proton number but same neutron numbers. These are called the isotone. So if I write it in a brief, so it is first isotope, same proton number but different mass number, right? What are the examples of isotope? That is, suppose hydrogen, very pretty, well known, 2 1 3 1. Look, the proton numbers are same 1, but the mass number are different. Okay, so this is the isotope. Next is that isobar. What is isobar? Same mass number but different proton number. Clear? Example, suppose nitrogen 14 7, carbon 14 6. So look, proton number is different, mass number is same. Clear? So this is the isobar. Now isotone. What is isotone? Isotone is that same neutron number but different proton number. Okay. So here example, suppose potassium 39 19, calcium. 40, 20. 1 marks question for this. What do you mean by isotone, isotope? You can get it. There is a possibility. Okay. And whenever you will write it, please write it with the example. Without example, it doesn't work it. Okay. So, now I will continue with the radioactivity. What you mean by radioactivity? First, scientist Becquerel has introduced this concept of the radioactivity. What he have done? Basically, once in a dark room, he left an uranium salt wrapped in a black paper on a photographic plate, right? After some days, he was surprised that photographic plate has been affected by that uranium salt, okay? Later, after some time, some observations made, and he had introduced that, or he had discovered that from that uranium salt some radiations are there, or some radiations has detected from that uranium salt, which changes the photographic plate, right? And from this concept he had proposed that some elements are there which has some special features which is called the radioactivity. Clear? And he has said that some elements have the special feature which is basically, first of all, he had introduced as a radiation, right? Afterwards, he had named its name as the Becquerel rays. This radiation's name was Becquerel rays. Okay. Afterwards, it was further observed and further research. It has been said that actually some elements shows some spontaneous radiation, which is called, and these elements are called the radioactive elements, and the spontaneous radiation which is made by that elements is called the radioactive rays. Okay, so why these spontaneous radiations are present in some elements? So the main thing is that, or the observation has said that, look, there is a stability between, or there is an equilibrium in the number of electron and number of neutron and number of proton in an element. For the suppose potassium, it has 20 neutrons and 19 protons. Okay, so when we goes upward, that is up to after 90, 91, 92 and goes like this, but as the atomic number increases, the number of neutron in a nucleus also increases in a rapid manner. Okay, so therefore, as the number of as there is an inequilibrium between the number of proton and number of neutron in an atom, then there there is a huge change of energy inside the nucleus, and that change of energy is being stabilized by that spontaneous radiation. Okay, so because all of you know, I don't know whether you know or you know it or not, the thing is that in the nucleus, for the stable nucleus also, for the potassium, calcium, all the nucleus are there. For each and every nucleus, inside the nucleus, there is always a conversation between proton to neutron and neutron to proton. Always it goes on by the exchange of pi meson particle. Okay, as this exchange of pi meson particle goes on, therefore what is happening? Proton is converted into neutron and neutron is converted into proton. So for this conversation, there is the energy which is called the nuclear energy or nuclear force, which has a range of 10 to the minus 13 centimeter, for which protons, though are they positively charged, still are closely bounded in that nucleus. But after a certain time or certain proton number, that is after 90 or 92, this conversation of the pi emission particles being very rapid, and that's why the nucleus become unstable and the nuclear force become unstable. So to stabilize the nucleus started to radiate the excess energy that is produced due to that pi emission particle conversion. And for this spontaneous radiation of energy is basically the radioactivity. Okay, and for this conversation, as the energy is released, this energy are released by three ways basically. Okay, first is that some helium nucleus can be released from the nucleus, which is basically called the alpha ray or alpha particle. Second is new electron can be released from the nucleus. Though we know that electrons are only present in the orbit, but it is the exceptional case where electrons are being released from the nucleus. Okay, and as the electrons are released, it is known as the beta particle. Okay, and gamma ray. Gamma, please be careful that gamma is not a particle, it is the ray. Okay, it is the electromagnetic ray. Why it is released, I will explain it later. But these three things are being radiated from a nucleus, that is alpha ray, beta ray and gamma ray. Okay, so in the next video I will discuss it in the further. Okay, thank you.